Also, welcome to this talk on sustainable software engineering, building carbon efficient applications. My name is Asim Hussain. You can find me on Twitter, or actually you can find me anywhere, everywhere as Jawake. If you see a Jawake somewhere on the internet, it's probably me. My bloggers on my website is asim.dev, and they find out a bit more information about me. And I'm what's called a cloud or developer relations lead, green developer relations lead at Microsoft, or green cloud advocacy lead at Microsoft. Whatever makes the most sense to you, that's my title. But I'll talk a little bit about kind of what my role is and kind of why I do what I do in terms of my job later on. Son Micah was born about 2 years ago now, and just before he was born, a friend of mine gave me some really great advice, actually, which was my wife had decided to breastfeed. She said, well, you're not going to have an opportunity to have that kind of quality time with your son. So take the nappy changes. She'll have to do breastfeeding. The rest of the time, he's a shared resource. Take the nappy changes, because the nappy changes are going to be just you and him. I was like, fine, that's a great idea. I told my wife, and she was very, very happy with the idea of me dealing with the nappy changes. And then about a couple of days later, she turned around and said, actually, Asim, I've decided we're going to use cloth nappies, not disposable nappies, cloth nappies. Now, if you've never seen a cloth nappy before, and you maybe have got an impression of them, they actually are quite advanced these days. They have elasticated waistbands, there's bamboo inserts, it's okay, they're pretty advanced. But the reality is you have to deal with poop. You have to deal with poop all the time, and he poops 8 times a day. You get very, very used to dealing with poop, and we did it because we're environmentally conscious family. We would do these things, but essentially we chose to use cloth nappies from an environmental perspective rather than anything else. And yeah, you get very, very used to dealing with poop. It's not a problem. I'm happy to talk about poop for hours on end. Anybody wants to talk about it now. It gets everywhere. It gets all over the place. Sometimes I'll be in meetings, and somebody else in the meeting call and go, Asim, what's that on your face? And I go, don't worry, it's just poop. So you get very, very used to dealing with poop. It's just something normal. But after, I can't remember exactly how long. It was a few months after I started this whole thing. I realized basically that how come I was willing to deal with poop 8 times a day? How come I was willing to deal with poop 8 times a day for the environment, and yet I had never, not once, in any single architectural meeting, in any Scrum meeting, in any design meeting, at any point, I'd never raised my hand and asked, well, what's the greener option? How come I was willing to do this thing at home, but at work, I had never really asked or figured out or even tried to implement something the greenest way? And that started me on this huge journey to kind of like, well, what does that even mean? And yes, I never asked in a technical meeting, like, what is the greener option? And that really started with me on this journey. And I think the first thing I did was I actually reached out to a friend of mine in the UK who's a member of the Green Party. He's in tech, but also a member of the Green Party in the UK, the Green Political Party in the UK. And I asked him, like, what do you do? What do you suggest? And he said, well, look, I don't know, but reach out to these guys, to these people. So it's an online community called climateaction.tech. It's the largest, I still believe, the largest tech community of people who are passionate about kind of the climate crisis and doing something about it, climate change and doing something about it. And there's a gradation of people in there, but there's all sorts of different people, and you can go in there, and I'll ask questions in there, and I will get an answer, very detailed, very methodical, very good answer within minutes. It's a very active community of very knowledgeable people. And so I arrived in there and I started asking lots of questions. What is the greenest way of doing these computing solutions? And again, they pointed me in lots of different directions. There's lots of academic work that's done. There's lots of academic papers. There's a few books, but very domain specific. And again, I spent like a good 6 months of my life just reading dry academic papers long academic papers and just doing a lot of research to kind of grab the information together. But then I learned a lot, but I also realized I can't expect the next person to come along to have to do exactly the same thing. If we need to really do something in this space, if we need to move this thing forward, we need to get all that knowledge condensed and structured in an easy to access form. And that's when we launched what we call principles.green. And what this is principles of sustainable software engineering, and essentially growing this field of sustainable software engineering. Now, I didn't coin the term sustainable software engineering. It was coined in a Mozilla Foundation. There's many different meetings in the Mozilla Foundation, in a Mozilla Foundation meeting. And I thought, that's a really good name. Let's latch on to that. And what we worked on was actually to be a sustainable software engineer, you need to broaden your knowledge. It's not just how do you write code most sustainably, because code runs on a computer. How does that computer work? That computer uses electricity. How is that electricity bought and sold on the internet? And in fact, we're building stuff for users to use. What is user behavior? How does the psychology of that work? So you need to broaden the domains of your experience. And what the principles tries to do is it tries to very, very quickly give you that breadth of knowledge. And once you've got that breadth of knowledge, you can then see solutions, sustainable solutions. It actually kind of points you in a direction. And I'll give you a quick overview of that later on. But I'd also argue that there's two philosophies of sustainable software engineering. There's the things you need to know, but again here, there's two philosophies of sustainable software engineering. And the first is that everyone has a part to play. I should mention before, what is this thing on the left? So this is a report from an advertising agency called Ogilvy in 2010 called Mainstream Green. Now, there's different studies out there about what is the size of the green audience, et cetera, et cetera. I love this because it's from an advertising agency. An advertising agency which everybody uses, whether you're somebody who pumps out lots of fossil fuels or somebody in a green audience. So I kind of trust their numbers because they talk to anybody and it's all about selling. And 10 years ago, what they analyzed from the audience is that 16% of people identify as super greens. Because you're in this talk, you're probably a super green. And the other end of the spectrum are green rejectors, so kind of climate deniers. And this is 10 years ago, so I think arguably now things are just a bit more polarized. There's more climate deniers and there's more super greens. That's kind of the move. Super greens are people, we acknowledge the scale and the importance of the climate crisis, and we're working hard, or we're trying to find ways that which we can do to solve the problem. So the super greens is the audience, primarily the audience of sustainable software engineers is going to come from super greens. It'd be very, very, very useful. It'd be very useful if we could control what all the super greens would do at any single moment in time to get the biggest impact on the climate crisis. It'd be really useful if this year we could tell everybody, okay, now everybody, please now focus on migrating to the cloud, because that's more efficient than the other solutions. Okay, next year, now everybody focus on writing really efficient C++ code. That's not how the world works, okay? These super greens, everybody on this listening to this call right now, you're spread thinly across almost every single domain in computing. I start from designing user interfaces to designing silicon. Like, it's spread across everywhere. And where we failed in the past in kind of this space is we've not really given everybody, we've not really spoken to everybody. We've only spoken to a thin sliver of people who we think have in engineering, who have the greatest impact on the climate crisis. That's not what the sustainable software engineering, its philosophy is everyone has a part to play. There is something for everybody. Wherever you are, whatever industry you're in, whatever domain, whatever sector, there's something that you can do, and sustainable software engineering will give you a direction to go in. And the other thing is sustainability is enough. Now, I speak to people who've been in this space for decades, like in the engineering sustainability space for decades, and they've seen a sea change in the last couple of years. Years ago, no one was interested in talking about sustainability at all. So when you wanted to talk about sustainability from an engineering perspective to a customer, to somebody, you had to wrap it in a different pill. You had to You have to say you're talking about cost reduction. You have to say you're talking about performance improvements, but really in your heart, you're doing this from a sustainability perspective. That's changed. Now, sustainability is enough. If you're a sustainable software engineer, there are many advantages to building sustainable applications. They're almost always cheaper. They're almost always faster. They're almost always more resilient. But the reason you, as a sustainable software engineer, is doing what you're doing is because of sustainability. Everything else is an added advantage. Everything else is just a great way to convince people. But the reason you're doing this is sustainability. Those are the two philosophies of sustainable software engineering. It's a movement. So the first, and now I'm going to really quickly go through some of the principles. I won't have time to go through all of them. I'd rather leave time at the end for questions if you have questions. I'm going to try and go through the first three at least in the time I have. So the first principle of sustainable software engineering is related to carbon. What do I mean by carbon? And what it is when I first started on this thing, when I started talking to people, what I want to build green applications. I realized quickly that to different people, green means different things. They have different focuses. They have different personal priorities. But it makes it very difficult when you're talking to people you need to make sure you're talking about the same thing, to be honest with you. So what we're talking about here is carbon. And so when I talk carbon, we're talking about greenhouse gases. So the greenhouse gases are gases that are in our atmosphere. They're acting as a blanket, warming up the planet. Very, very importantly, and I do like to explain this every single time because it's a common kind of attack back. It's a natural phenomenon. It's 100%, it's natural. Greenhouse gases increase and decrease over thousands of years in natural cycles on the Earth. And that means the temperature increases and decreases naturally. And greenhouse gases are not the only driver of temperature, but is one of the drivers of temperature. And it's a natural process. But it happens so slowly. It gives time for animals, plants, and now humans to adapt. It gives us time. Imagine forests slowly moving across continents. Those are kind of the geographic timescales that we're talking about. But now through human activity, it's happening too fast. It's happening in an eye blink. And the real issue is adaptation. It's happening too fast for animals, plants, and humanity to adapt to. We can't adapt fast enough, and that's the problem. So it's a natural phenomenon happening too fast for us to adapt to. That's the challenge. Why do I use the word carbon? Well, there's actually quite a few different greenhouse gases in the atmosphere. This is very important. You're going to see later on why I'm belaboring these points. So that there's lots of different greenhouse gases in the atmosphere. They have different warming effects. The most common is carbon dioxide. But there's other ones. For instance, methane. Methane has 20 to 80 times the warming effect of carbon dioxide. But it would make life very, very difficult if we always spoke about specifically, carbon, methane, So we normalize everything into what's called carbon dioxide equivalent. So we call 1 ton of carbon dioxide, we call 1 ton of carbon dioxide equivalent. We call 1 ton of methane, maybe 20 tons of carbon dioxide equivalent. And that's why we always normalize the carbon dioxide equivalent, which often gets shortened to just carbon. So when we say carbon, we're really talking about every single greenhouse gas in the atmosphere. And kind of what is the goal? Like, what is the goal? So the challenge is carbon. What's our goal? What are we driving towards? This is this is all very opinionated from me, and I think it's an important opinion because it leapfrogs you forward into a direction. Our goal might be net zero or something else might be the goal, but the direction we go in is reducing waste and being more efficient. As engineers, we always want to be more efficient. I never want to if an engineer came to me and said, I like being wasteful, you wouldn't hire that engineer. You'd let them go. Who wants to be wasteful? And that's the same when it comes to sustainability, when it comes to green. It's all about being efficient, but being efficient with a resource of carbon or a resource of a resource. I think a great example of this is internal combustion engines versus EVs, versus electric vehicles. Why are EVs greener? Why are they greener? What makes it green? It makes it green because they're much more efficient. If you take oil and we take that crude oil from the ground and turn it into petrol or gasoline, we lose 50% of the energy potential of that crude oil. It doesn't get turned to something else. It gets lost as heat or something else. It just goes away. We've lost it. Petrol weighs something. So to get that to your car, we lose about 20%. So again, we're down to 40%. An internal combustion engine in your car is only 20% efficient at turning the energy potential of petrol into forward motion. The rest gets turned into heat. 8% efficient. No one should be proud of making something that's 8% efficient. An engineer shouldn't be proud of making something that's 8% efficient. It's just that there's so much oil and it was so cheap for such a long time, we didn't care about 8% efficiency. But that's kind of what one internal combustion engine. Let's talk about an electric vehicle. If we're using solar, we consider that 100% efficiency, because at the end of the day, the sun's rays are free. And if you weren't going to trap it with a solar panel, it was just going to hit the ground or a roof. So it's 100% efficient. Moving electricity to a car is incredibly efficient. We only lose about 2%. It's a very conservative estimate. We lose about 2%, even over long distances, to get that electricity to a car. I've given this presentation 7 times, and I always forget to change this last number. It's not 75%. It's between 60 to 70% is the energy efficiency of an electric motor to turn electricity to forward motion. It's about 60 to 70% here. That's why it's green. It's green because it's efficient at turning a resource into something. That's really what it's all about. And that's why the first principle of sustainable software engineering is to build applications that are carbon efficient. Everything emits carbon in our life. Everything emits carbon. We are not going to get away from emitting carbon. When it comes to your applications, a direction to always face in is that if you're given 2 choices for direction to choose, pick the one that is most carbon efficient. And by that I mean that gets the most value for each gram of carbon that your applications emit. And that's what that gives you your primary focus and direction on everything, is to be carbon efficient. Some people don't agree with me on that one. It's very opinionated, as I say, but I think it's good because it gives you direction. The second principle is electricity. Now, I used to think electricity was incredibly clean. You don't think of it as dirty, do you? When you plug your laptop into the wall socket, your hands don't get dirty. There's no smell. There's no exhaust pipe on your laptop. Imagine if there was. There's no exhaust pipe on your laptop. So we think, or at least I used to think of electricity as incredibly clean. But in fact, electricity is one of the most dirtiest things on the planet. That's because most electricity is still created through the burning of fossil fuels, namely coal, and varying grades of coal. Coal is not just always a thing that you see. You can get quite dirty coal as well. It's just dirt, just burning dirt, basically. And so electricity is created through the burning of fossil fuels, a lot of it. And it's about half of all pollution, greenhouse gas pollution in the world is from the creation of electricity and heat, electricity and heat, both of them. So it's a big part of the problem, a huge part of the problem. Yeah, and so I think that we need to have. So as me, as somebody coming into this, then on my journey learning this stuff, I realized I didn't even know much about electricity at all. I depend on electricity. My entire career depends upon electricity. You cannot run a laptop or computer without electricity. How can I reach this advanced stage in my career without really knowing much about this thing? I completely depend upon. I thought that was quite crazy, and I realize now that electricity is a large part of being a sustainable software engineer, is having a literacy about electricity. It's very, very important. And so I'm going to teach you now kind of the key things that you need at least to understand the rest of this course, and that is, how do you measure electricity? The standard unit is a joule, and a joule is a volume of electricity. Then, but that's not that useful. What we talk about is this thing called a watt. A watt is a flow of electricity. So 1 watt means 1 joule per second. And therefore 1 kilowatt is 1,000 joules per second. But then we get this thing called a kilowatt hour, which is again a volume measurement. A kilowatt hour is, what if you let that 1,000 joules per second run for 1 hour? What is the volume of electricity that you will get in the end? Excuse me. And And that's what kilowatt hours, and kilowatt hours is kind of this term that you'll hear constantly when talking about kind of energy consumption of software and hardware devices and things like that. It's a kilowatt hour or a watt hour or something along those lines. And yeah, it might have made you really depressed about electricity. It might have made you super depressed about electricity. It's a big part of the problem. But what excites a lot of people is it's also a huge part of the solution as well. If we look at kind of the total worldwide energy consumption, that's not just electricity, but energy consumption, it's 18 terawatts. Now you know a terawatt is a flow per second, but it's 18 terawatts is the worldwide consumption of energy. So everything that we're doing, all the pollution we're pumping out into the atmosphere is to create 18 terawatts. With wind, we have about 1,000 terawatts available to us. Now that is if we captured every single gust of wind on the planet, we would have about 1,000 terawatts. And a lot of that doesn't even have to be the wind farms that you see. You can actually have wind farms quite far out into the ocean. But that's 1,000 terawatts that's available to us for wind. So that's quite exciting, right? Like, what's that? 200 times more than the energy we need for everything in the world is available through clean wind. But the really exciting one is solar. So there's to get 170,000 terawatts is available through solar. Now, to get that, you'd have to have a solar panel the size of half the Earth. But there's so much more available to us via solar. And what's that? 10,000 times more available to us via solar than we have through everything that we're doing right now. And it's very easy to achieve. Like there's some studies which show that to get everything that we need to survive as a species just on solar, we just have to put a solar panel on everything that faces upwards, and then we can make it. So there's lots of things. And what I'm pointing out to you is that this one I'm talking about isn't crazy. We can totally achieve everything we want to achieve. The technology is available right now. We're not sort of short of technology. We don't need to wait for a miracle. Everything's available. We just need to make decisions to make it happen. And that's kind of why the second principle of sustainable software engineering is to build applications that are energy efficient. And as software engineers, you're probably thinking, oh, excellent, like I know how to do that. And in fact, it's actually quite a common thing that we're already doing these days. I can't reach my phone, but if I was, for mobile devices, it's quite a common thing to look at the energy efficiency of our software because we care not about the carbon cost of electricity so much, but about making sure that the battery life of our devices don't drain out. It's kind of the driving force of that. But really what we want to do is we want to look at the energy efficiency of everything, even stuff that's plugged into the wall, even servers that are plugged into kind of data centers. That's what we need to look at as sustainable software engineers, is we need to look at the energy efficiency of all of it. And it's quite a complex thing that I fortunately have the time to go into great depth, but I recommend you look at the 8 principles on the principles.green that want to really get a good insight into some of the other things, especially look at the one called energy proportionality. It's a really interesting one. Anyway, so there's another aspect of energy which I'm now kind of brought you towards, this idea called carbon intensity. And I got this from a show that I listened to called the Energy Transition Show with Chris Nell. I just recommend listening to that podcast if you want to listen to something. It's a really interesting podcast about the energy transition into renewable power. And it taught me into this idea of carbon intensity. And what it means is actually not all electricity is born equal. Some electricity is created through burning coal. Some electricity is created through renewable power plants. What electricity are you getting? What is the stuff coming through this wall socket right now? Is it the clean electricity? Is it not clean electricity? The measure of how clean or dirty electricity is called carbon intensity. And it actually has a standard definition, which is this. And now you should understand why I was explaining all these terms earlier on, because you need to know that so you'd understand carbon intensity. And that's grams of carbon dioxide or grams of carbon per kilowatt hour. So for every kilowatt hour, which is a volume of electricity, how many grams of carbon were emitted into the atmosphere to create it? The global average last year was 519 grams of carbon, which is about half a kilo. What does half a kilo of carbon look like? Just imagine in your hand half a kilo of ash, and that's kind of the right way to think about it. It's half a kilo of ash. Different countries are different. France is usually very, very good. France is usually very, very low. and so does Sweden and Denmark and Norway too as well. But usually very, very low. France especially is very low because of all the nuclear that they have. UK is also pretty low, but it depends region by region, depending on how many renewable resources you have versus how much electricity just is coming from coal power plants or something like that. There's a really great resource called Electricity Map, and I'll show you some of this. The Electricity Map is really, really good. I mean, you can go to the website and you can hover over different areas, and it'll tell you at that moment in time what is the carbon intensity. So you can see, like, Germany was 185 at this time. Poland was quite dirty. It's cleaning itself up. India's very dirty. Australia's very dirty. Some's coal in those regions. Eastern US is also very dirty. West US is cleaner. So different regions, depending on the renewable, on the power plants they have in those regions, will have dirtier and cleaner electricity. This is why, as a sustainable software engineer, you need to understand kind of a lot of broader things. But even already, you should probably be having some ideas about, well, actually, that's interesting. What are some things I could do? Maybe I could run my server in France. Yeah, there's things you can do which can have a measurable impact on the carbon impact of your applications. But as well as changing over regions, a really interesting aspect of carbon intensity is it changes over time as well. It's because of the variable nature of renewable resources, of some renewable resources. So wind and solar are renewable. However, they're also variable. Like, we can't control the wind and sun. When the wind's blowing and the sun's shining, we're going to take electricity because that electricity was essentially created for free. Why would you not take it? And there are actually some crazy reasons why you wouldn't take it, but I won't go into them. But they are discussed on principles.green. They open up some other avenues as well. But essentially, like, the demand is the same. Oh, something about the electricity grid, and I thought it was really fascinating. Everything we use in our life uses batteries. Everything uses batteries. So I just assumed everything else uses batteries. Batteries are everywhere. They're not everywhere. Our electrical grid has very, very little storage inside it. Typically what happens is that if you turn on your washing machine at home, the utility has to produce the electricity, extra electricity, to match your washing machine. It's all matched in real time. There's a little bit of storage, not a lot, which means that if this is the demand right now, they kind of make up with coal and gas. If the wind and solar goes down, and the wind stops blowing, the sun stops shining, they have to burn more gas and burn more coal to meet the same demand, or you get like a brownout, right? Your washing machine stops working, right? There's very little storage. And what that means is the carbon intensity changes over time. There's moments where it's very, very low. In fact, there's moments when it's zero. There's moments when it's 100%, when the electricity coming through has no carbon cost at all, or the marginal carbon intensity has no carbon cost at all. And so therefore now you know that in different regions the carbon intensity increases and decreases, and over time the carbon intensity increases and decreases. So there's things you can do, like maybe if you've got a machine learning model, a very, very long, laborious machine learning model that takes days and days to run, can you expand the resource of running it during the cleanest moments and kind of shut it down during the dirtiest moments? If you now know regionally, maybe you've got a workload that is continuous. Maybe you consider running it in a region which has the greener electricity rather than in other places. There's lots of limitations for this. Maybe you need to stick things close to users and you don't have any choices. But if you do have a choice, and a lot of us do all the time, if you do have a choice, think about the carbon intensity of electricity as part of the decision for where to make that choice. There's different sources. Where do you get the data from? If you're in the UK, there's a free resource called carbonintensity.org.uk. You don't even need, it's supported by universities, you don't even need an API key to register. It's just an API that you hit, and it always gives you the latest data from the national grid in the UK. There's a non-profit in the US called What's Time, and they tend to have better data for US-based grids. And the Electricity Map is based in France, and so they generally have better data for kind of European. They both have good data for all regions, but it's a slight preference for which region you're in. What time Electricity Map is a paid for resource, but carbon intensity is free. And that's why the third principle is consume electricity with the lowest carbon intensity. Like if you have choices, that's a choice you can make. When I was first looking at this and I was trying to figure out, well, what can I do? How can I make a decision in a meeting that would impact carbon intensity? This is one of them. I argue that when I used to have cron jobs, when I do like kind of batch jobs, overnight jobs, I just used to set an arbitrary time. Can you set a time? Can you look at carbon intensity on UK? Can you set a time which is, I don't care when it gets run. Really, I need it run by 8 in the morning. That's it. Can you dynamically pick a time and have it run at the lowest carbon intensity moment? There's loads of choices and options that you open up to. I'm see how much time I got. I'm going to really quickly go through this. So there's also this concept of embodied carbon. I talked about electricity constantly, but everything that we create, including things like mobile devices, all of it emitted carbon in its creation. And in fact, quite a lot of carbon gets emitted when things get created. No matter how clean electricity I use my phone, I will probably never offset the amount of carbon that was emitted through its creation. That's mostly because they're so efficient at electricity. Laptops slightly less so, but still very good. Servers, they're not that efficient, not because they're poorly efficient, just for other reasons. And so the equation is different there. What do you do as a software engineer? Well, the important thing I think you do as a software engineer is you just make things last longer. Right? Why do I have to replace this every 3 years? Why? Because all the software is always pushing the limits of everything. And by 3 years down the line, nothing really works as good as I want it to work. That's our fault as software engineers. So why we're pushing everything all the time. So we need to do it that way. And I'm actually just going to skip the rest. And I'm going to get to the end because I think I'm out of time. Let's quickly talk about energy proportionality. This is really interesting. So there's an aspect of computing, and all devices have the same issue, which is the more you use it, the more efficient it becomes at converting electricity to useful function. An idle server still consumes a lot of electricity. So really what you want to do is you want to make sure everything's utilized as much as possible, because it actually makes the whole thing more efficient. It's like driving a car at like 2 miles an hour is actually less fuel efficient than driving it at like 50, 60 miles an hour. It has an optimum peak efficiency, and that's where you want to get to with the hardware. And that's my hardware. So again, principles, I recommend you go to them and read them all. There's a number of others. There's networking, demand shaping, and measurement and optimization. One of the things that we're working on right now, myself, even at Microsoft, as my role at Microsoft is kind of getting this content together and really trying to figure out how to do Microsoft services most efficiently. We've just started to get some of this information out there. So you go to our docs.microsoft.com, you go to that link, it's to docs.microsoft.com. We've started to write some stuff for Kubernetes, how to do Kubernetes on our services. What are some things to consider to run it more sustainably? We've also just launched a blog, and this is kind of an internal blog, but not internal, external blog, but with lots of different people from across Microsoft, hardware, energy, Windows, cloud. It's really exciting. It's a lot of us kind of just sitting there thinking like, what are some ways we can do software more sustainably? And we're just starting writing some stuff out. It's very early stages, very nascent. We're all just figuring stuff out. So you're just going to find the latest things that we're thinking of. You're going to find it there. Yeah, and that's it. Thank you very much.